Knock, knock. Yes. Hi, everyone. This is Deepak. Today, I'll talk about ZK login. A little bit about me. I'm a research scientist at Mysten Labs, the company behind Sui blockchain. I'll talk about ZK login, which is a new feature that we have launched. It is deployed on the Sui blockchain. At a high level, our goal with ZK login was to create a really user-friendly wallet experience that makes onboarding much more easier for users. So exactly what is the problem, right? Just to give a little bit of context, a recent study kind of shows that there's about 100 million active crypto wallets today. And at the very least, this is like an order of magnitude low than the number of total internet users. So now the question is, why is there such a big gap? Now there may be many reasons for it, but I contend that one of the main reasons is how hard it is for users to use web3 applications. Any of you who has onboarded onto a wallet can probably attest to what I'm talking about, but even otherwise, this is sort of a typical onboarding experience you'll see today. First of all, you'll have to install an extension or an app, which in and of itself is a bit of a hurdle because you, as a user, you're supposed to take an action. Let's say you go ahead, you install an extension, and then you're supposed to remember a 16-word recovery phrase, right? No one likes this. It's sort of the equivalent of remembering, let's say, 4 or 5 passwords at once. No one likes remembering even a single password. And even some wallets even force you to make sure that you actually have remembered this and confirm that you have remembered it, and they kind of won't leave you until you actually fill this up. And finally, after you've done all that and you haven't uninstalled the app, you can then go ahead and use your blockchain. And this is kind of the state of where Web3 wallets are. And so the key hypothesis, you can say, is that we think that mnemonics alone aren't going to get us mass adoption for blockchain applications. So what do we want, right? At a high level, the idea is to think if we can make it as easy to sign blockchain transactions as it is to, let's say, sign in with Google or Apple on the internet, right? When we browse the internet, when we go to different websites, people don't create a new password for every website you browse. People usually use an existing account that they use and kind of reuse the account to log into different accounts. Kind of extending the same idea, we ask ourselves, well, can we sign blockchain transactions using existing accounts? And this may sound like magic a little bit. Hopefully I convince you otherwise in the next few slides. But technically speaking, the way this works today just on the internet is broadly using OAuth. Now OAuth, at a high level, the way it works is you pick an OAuth provider of your choice. There are many OAuth providers, let's say Google, Facebook, Apple, etc. And at a high level, OAuth designs the flows to convince an OAuth client, which is the website you're logging into, about certain information from the source account. Let's say that is your Google account. And this is how things work on the internet today. And we ask ourselves how we can realize a wallet with that. And it turns out that it's not too hard to do it if we are willing to introduce a custodian into the picture. What do I mean by that? Well, if there was a party who can hold a private key for you and kind of do this transaction signing for you, then that party can just be the OAuth client. You expose a simple and user-friendly experience to the user. The user never needs to care about what it means to remember a recovery phrase or any of that. And so if user experience was the only goal, then this could work in principle. But really the challenge here is to see if we can do all of this in a way that we avoid having to introduce a custodian And this is for many reasons, just to reduce the number of single points of failure, just to avoid trusting yet another entity. And so this is exactly what we do. ZK Login allows users to use OAuth along with zero-knowledge proofs to sign blockchain transactions. It is everything that I promised. It's primarily very user-friendly. It's also important. Privacy is important here in the context that these existing accounts may have sensitive information attached to the user, so you don't want to necessarily reveal this information to arbitrary parties. So let's get into the technical portion of the talk, and I'll explain how it works now. A brief primer on OpenID Connect. So OpenID Connect is a specification that sits on top of OAuth. So not every OAuth provider implements OpenID Connect, but luckily for us, most of the popular providers do. And I'll only cover one detail of OpenID Connect that is relevant for us, which is the identity token. So as part of the OpenID Connect flow, as the user is signing in to Google or Apple or whichever it is, there is this ID token that gets sent by the OpenID provider to the OAuth client. And this ID token looks something like this. It has a header, a payload, and a signature. Most widely used is RSA signatures. So basically, the OpenID provider is issuing a signature over basic user information in order for the OAuth client to consume and basically get basic information about the user. So this can be things like the name of the user, the email of the user, and other such very basic things. So the key idea for us is if we can use a JWT as the equivalent of a private key. So everything you would imagine you would want to do with a private key, signing transactions, etc., we ask if it is possible to do with the knowledge of this JWT. This is a more realistic JWT from Google. So the payload has many fields. I'll just cover some that are sort of relevant to the talk. So nonce is an important one. So nonce is the only field in this payload that the client can control. So the nonce is there to prevent replay attacks. So as a client, you can set a nonce and ask Google to sign on it, and you can then check that the nonce that was returned was the same one that you set, and so you're convinced that there's no replay attacks there. But other than that, it just has very basic information like user identifiers and such. Okay, so we have this JWT. Well, how do we authorize a transaction? Now, there's many ways to do it. The way we go about it is to create a key pair. I call it an ephemeral key pair because as a user, you do not need to remember it. You can kind of forget it as soon as you use it. And we insert the ephemeral public key into the nonce field. So as I said, nonce is the only field in this payload that the client can control. So we exploit that property. So what do we have here? Basically, we have a certificate over the freshly created key pair. And so the basic idea is that we can then use the corresponding ephemeral private key to sign transactions. So we authorize transactions with JWTs in sort of a two-step way. You create a key pair, insert the public key into the nonce, and then use the corresponding private key to sort of sign transactions. A second challenge is identifying the user while respecting users' privacy. So what do I mean by that? So as I said, this JWT has certain user identifiers. ISS is an identifier for the OpenID provider, Google. AUD is an identifier for the client, which in this case would be the wallet. SUB sub is an identifier that identifies the user uniquely, and that is where some privacy concerns arise. Basically, some providers like Google use the same identifier for the user across all the websites and apps that the user may sign into. So, if you're signing into Google in 100 different apps, all the apps will receive and identify you using the same sub value. And so the challenge for us is, well, how do we identify the user on chain without necessarily making the sub value public? So the way we do that is by introducing a salt. A salt is nothing but a persistent secret, so someone has to remember it across sessions. And the sole purpose of it, I kind of want to highlight this, the sole purpose of it is for unlinkability, meaning unlinking the two identities, the on-chain and the off-chain. Specifically, it doesn't play any role in security here. So the whole point of it is to just unlink the two identities. A minor note: instead of sub, we could also have based the on-chain account on other fields in the JWT. So, for example, we could have created an email-based wallet if the JWT provider sends an email. And so there's a lot of flexibility in how we construct an on-chain address for the user, depending on the claims that the JWT provider gives us. So a key question is, who maintains the salt? It's sort of a tricky one, because the whole point of our system is to kind of make sure that the user doesn't need to remember yet another secret. Now, the good thing for us is that the secret is not the same level of sensitivity as a mnemonic, because it isn't for security, it's only for privacy. And so we can exploit that a little to make our task easier. So for example, in some cases, it may be possible to just sort of store it on client side so that the user actually never sees it, and it kind of just gets used whenever the user is signing a transaction. Some edge cases arise to kind of sync across devices that kind of need handling. I'm happy to talk about those for those that are interested later. It may also be a reasonable choice to store it on the server side. By that, I mean that each wallet can sort of store the salts or back up the salts of their users, and kind of create an experience for the users where they kind of are not exposed to the salt. Again, there's many options for how we can store the salt on the server side. This can be stored even in plain text if the privacy model kind of is okay, because again, the key point here is that the user has a different account with each app. So the salt is kind of different across apps. So maybe it's okay for an app to kind of store the salt on the server side in plain. But interesting models like using MPC are also possible here. Finally, I haven't kind of explained what all claims are in the JWT, but I have kind of touched upon how certain claims are sensitive. For example, the sub can be sensitive. And I've also said that there are claims like email. So clearly, you kind of don't want to reveal the JWT publicly on chain, just for the privacy reasons. And there may also be some security reasons for which you may not want to do that. But even just for the privacy reasons, it's probably not a good idea. And so here we use the magic box of snarks, and we prove that you have a valid JWT, and you know the salt that kind of derives to an on-chain address. I've kind of briefly listed out the somewhat precise actions that we kind of implement in the snark circuit. So the snark will have to check the signature on the JWT. It will have to check that the nonce has the ephemeral public key, and it will have to check that the address derivation was done appropriately. So I'll talk a little bit more about the snark operations a little later. But yeah, just to quickly summarize, so the whole process starts with creating an ephemeral key pair, injecting that into the nonce, getting a JWT from the OpenID provider on the nonce, on the JWT, and then generating a zero-knowledge proof that proves its validity, and also proves the binding between the ephemeral public key and your on-chain address. And so every on-chain transaction, every on-chain ZK login transaction has two parts to it: a zero-knowledge proof and ephemeral private key signed transaction. So the zero-knowledge proof is there to bind the ephemeral public key to the address, and the ephemeral private key signed transaction is there to authorize the transaction. Finally, we want to be able to prove and actually submit a transaction in quite fast. So for the moment, which was Grot 16 to implement the previously explained Snark. But today proofs are slow, so we come up with a way to delegate proving to an untrusted ZKP service. What do I mean by untrusted? I mean that the ZKP service, even if we have one, cannot alone sign transactions. So even if it is fully malicious, it can't sign transactions and kind of steal users' assets. So you can also kind of ask if it is possible to do the delegation in a privacy-preserving way, which is a bit of an open problem for now. But I guess at a high level, the point is that zero-knowledge proofs can either be generated locally or delegated, and delegation is not too bad because it can be done without having to trust another entity here. Just quickly talking a little about the circuit itself. The main operations and the costliest operation is SHA-2. So as I said before, every provider we've seen uses RSA with SHA-2 today. So which means that, and basically those are the most expensive operations. We have some interesting tricks with regards to JSON parsing and other things to optimize the basically rest of the operations beyond other than the signatures. Today the prover is based on RapidSnark, and I'll talk a little about the latencies now. So this was benchmarked on a machine, on a not too powerful machine, I think about 16 cores. So the zero-knowledge proof generation takes just about 3 seconds. And the end-to-end transaction confirmation time is also about 3 to 4 seconds. The key point to note here is that a single zero-knowledge proof can be reused across transactions. So as I said before, you just bind an ephemeral key pair, and so you can then reuse the ephemeral private key as long as that is remembered, which typically is remembered across at least a session, but the length of a session kind of depends on the device. So if you're in a mobile context, maybe you can remember it for longer. If you're in a browser context, it can be remembered for a slightly smaller time. But the point is that this end-to-end latency is not really experienced by the end user for every transaction that they're signing. So there's a little bit of a nuance on what they actually experience in practice. Finally, as I said, we've deployed it on SUI, and so I have a small demo, which I hope it works. Yes, there you go. So user uses Google. Here, I don't know if I can pause it to add a little bit of comment, but the point is that the user is likely already logged into Google. That's why there wasn't a password prompt. It kind of automatically happened. And there you go. Let me see if I can rerun it just to see if it works. Yeah, okay, there you go. So today we support many providers, Google, Facebook, and Twitch, Apple, Slack, Microsoft, etc. We're also planning to add more. As you can see, this is where the zero-knowledge proof generation is happening. That's why it's taking slightly longer. But yeah, overall it is fairly smooth. Okay, just to quickly talk about some of the properties and interesting features that zkLogin gives us. I think the most interesting one is that it allows creating email or phone-based accounts. If basically whatever identity information the GWT has, we can use and create accounts directly for those. Now, previously I've mentioned the use of salt, but maybe in some cases, like if you're a content creator, it may be okay for you to reveal the email publicly, and then it kind of becomes a discoverable account. So there's like a one-to-one mapping between your off-chain identity and your on-chain identity, and anyone can see and know who you are based on just looking at your on-chain address. And that can be interesting. It's also possible to kind of create anonymous accounts. So maybe you hide a part of your email address and create one account for, let's say, I'm a Cornell alum, so all of Cornell users can kind of use a blockchain account, maybe for voting or something else. It's also possible to create embedded wallets. So what I mean by that is the typical wallet experience is always either you have an extension or a mobile app or somewhere where your wallet exists. But with ZK Login, well, you can just have a wallet directly in your app. So there's no need for another pop-up or another hurdle in the user experience for users. One of the concerns we've received from builders as we've launched it was with regards to security. So there are certain DeFi applications which care about high security and maybe they worry about keeping the account assets safe even if your Google account gets hacked, for example. And in cases like that, it can be useful to create like a 2 out of 3 between Google, Facebook, and Apple. And so then even if your Google account gets hacked, you're good. So that can also be interesting. And I guess last but definitely not the least, the whole point of this adventure is to create an account that is very, very, very hard to lose, which is kind of granted to us here thanks to the robust recovery paths in these existing accounts. All right, I will end my talk here. Thank you so much.
Great, very cool. Actually, before we get any questions, could you say a little bit about usage? Like how many ZK proofs are you generating every day now as a result of this?
I think, I remember sometime this year when we celebrated, 100K ZKPs overall. I'm sure we've reached, I don't know, 300K or something now in total. That's the number of ZKPs.
ZKP total,
yeah, so the number of on-chain ZK login transactions maybe more.
So this is a pretty significant use of
Yes,
ZKs in the world today.
Yeah, I think so. I mean, I don't have stats about other ZKP users like in Zcash and others to compare, but this it sounds significant. Yes.
Yeah, very cool. Yeah, please.
Thanks for the nice talk. And I wanted to ask, to what extent this application will be tied to these authentication providers, and in case, for example, they decide to not allow this product to connect, will the users be completely disconnected with the service, or is there a way for the users to then connect with a traditional path?
Yeah, so there's a couple different things here. So if we build the account from emails, then we have more flexibility because your email can be authenticated by different providers and potentially they can issue you JWTs on that, and we can then base everything on your emails and there's some flexibility there. But if we base it on sub, it is a little more harder because the subject identifier is by definition an identifier issued to you by the ad provider. Yeah, so I think it kind of depends, but it is certainly possible to do this in a way that you are keeping yourself flexible from the OpenID provider.
Thank you.
Hi. So any reputable OIDC provider rotates out their certificates every couple of weeks. How do you manage that?
Yeah, so one aspect I did not quite talk about is how the verification works in great detail. Basically, we need an oracle to fetch and post these public keys on chain. In the case of SUI, validators themselves perform this function. But if you want to instantiate it on another chain, I would imagine you just need these oracles to periodically check the endpoint. So basically, they post it on HTTPS endpoint. So the oracle just needs to repeatedly check and kind of fetch.
Okay. And second question, JWTs usually have a very strict expiration date. How is that managed?
Yeah, so there's a couple different ways of dealing with expiration. What we do is we set up a different expiry time just to avoid the thing that you said. So we don't just insert the ephemeral public key into the nonce, we insert ephemeral public key along with an expiration time into the nonce, and the expiration time is therefore controlled by the client. And on chain, we verify that you're not just setting arbitrarily long expiry times. So maybe you can just set something like 1 or 2 days, but not like 1 year.
Does that expiration date match the JWT's expiration date?
No, it's slightly longer.
Gotcha. Thank you.
Hi, I think this is a really cool idea. I'm curious about salts. if I had some uniform and reliable way of transforming identifiers for applications into salts, and I wanted exactly one different identity per application, could I just use that and obviate the need to actually store salts for applications?
So if that transformation is public, then everyone knows your Google or whatever identity, yeah?
Well, it's not necessarily reversible. It's, so for example, if I took the hash of the app ID and used that as a salt, I prove in zero knowledge that I have some application that goes, that the hash of my email in the salt is this.
Yeah, no, it is reversible, I think, because the space of the subject identifiers is small, and if you use a hash of app ID as a sort, then I can just brute force and find which of these corresponds to a given address, right?
Okay, thank you.
Yeah. It would be nice if we could do that.
Yeah.
So the salt is actually being incorporated into the ZKP in your thing, if I understood correctly. In principle, wouldn't it be possible to incorporate the salt outside of the ZKP or in another layer, or just on the side or something, maybe with a Peterson commitment or something, so that you could have a re-randomizable ZKP, or so you could reuse the re-randomization of ROS16, and then of course you would then need a browser plugin to use that, but then you could make the browser could make the ZKP once and then reuse it.
Sorry, the goal is to hide what from whom?
The goal is just to make it cheaper. So if the user's browser is doing this ZKP, then they're using a lot of different apps, then they could make the ZKP once,
I see,
and then their own browser plugin would enforce the OpenID connects, but then it would just use the single ZKP for itself.
Yeah, I don't think you can reuse it. Sorry, reusing a single ZKP across different apps may be challenging because different apps will have different JWTs. And so,
All right, sounds like maybe we can design this offline. Yeah, last question, please.
Would you consider private delegation using T's? Why or why not?
private delegation of ZKPs.
Yes.
And yeah, no, definitely it could be an interesting option. I mean, at the end of the day, the challenge is to delegate in a way that the delegatee doesn't know the witness. So T, if we can generate zero knowledge proofs inside T in like reasonably efficiently, then yes.
Thank you.
Cool, yeah, very cool project. Thank you, Deepak.